Alright, so the last lesson on Unit 2, or from Unit 2, is about Niels Bohr, who made what is the most advanced atom model that we will discuss in this class. Alright, so this is what we, at least according to us, there is actually a model beyond this, but it's outside of the scope of this class, but something you'll probably hear about if you ever take a chemistry class in college. But ultimately, understanding his model means that you'll be able to describe how electrons are placed around the atom and what happens when those electrons move around or change orbital levels. So, back in lesson 2.02, we left off with Rutherford's model, where he discovered the fact that there's a nucleus and that it's tiny, it's in the center, and then there's a bunch of empty space around it. And he thought that the electrons were just kind of like in one ring around the nucleus. So Bohr is going to take this just a little bit further. Niels Bohr determined that there are actually multiple rings in which the electrons can exist, and he called them orbitals. All right. So I mean, to him, it's kind of like the nucleus is the sun, and then the electrons are planets absorbing around, or not absorbing, rotating around the nucleus. All right. So real quick, in the picture on the left there, which guy do you think is Niels Bohr? So you might recognize one of the two people, especially if he had his hat off and he had his crazy Einstein hair. All right, so this guy is Einstein, and that is Niels Bohr walking right next to him. All right. Some details that you want to have in regards to these orbitals is that there is actually a set number of electrons that each orbital can hold. Now, it doesn't mean that each of these orbitals has to have this many electrons. This is just the maximum number they can hold. All right, so it'll depend on the atom that you're dealing with and how many electrons that are present as far as how many of these they're going to have. All right, so the first energy level, there's only 2 electrons that'll fit in there. So, like hydrogen has only 1 electron, so there'd just be 1 there. And then when you get to helium, that has 2 electrons, that orbital's full. So then everything else on the periodic table beyond that has to put electrons in higher orbitals. All right, so the second energy level holds 8, third energy level holds 18, and then it just increases from there. So these are the only numbers that you would have to know, so write these down just in case you get a question asked about it. But it's also good to just know in general that as you go farther from the nucleus, you are able to hold on to more electrons. All right. So, just a quick kind of review here. So, just in general, as you move farther from the nucleus, do the orbitals hold more or fewer electrons? You should be saying more. And can you come up with a logical reason to help you kind of remember that? All right, so if you think about it, here's our nucleus. And then we've got orbital 1, orbital 2. So like, what's going on as I draw those circles? All right, so hopefully you're kind of seeing that, oh yeah, as you get further out, the circles get bigger. So it kind of makes sense that they would have room for more electrons. All right. So back when Bohr was studying this, I mean, even now, we really can't see electrons under microscopes, but definitely couldn't back then. So what he ended up doing was he found a way to measure the energy of the electrons based on the fact that when you vibrate electrons, you can get them to give off light. All right? And what he discovered was that electrons that are near the nucleus have low energies, and electrons that are far from the nucleus have high energies. All right? So, what's kind of easier to deal with? High energy or low energy? What's easier to kind of provide? Hopefully you're saying low energy. All right. And I'm kind of trying to guide your thinking here. So we've got these positive protons in the nucleus and these negative electrons. What do positive and negative do? What do opposites do? So I'm hoping you are thinking of the term attract. All right. So because the electrons and protons attract each other, why do you think that those electrons that are in the closer rings near the nucleus need less energy to be held there than the ones in the farther rings? So try and think that through. Take a second, pause the video if you need some more time to think about it. But because those electrons are attracted to the protons, all right, they want to be near the nucleus. All right, so when these electrons are in those low rings, it doesn't take much effort to keep them there. All right, because they're really close to where they want to be. Whereas the farther the electron goes out, the more energy it requires to keep it there instead of, zooming in and running into those protons. All right? So that's one way you can help just make logical sense of what you're seeing here and understand the pattern of why low energies are needed to keep electrons in the bottom ring and higher energies are necessary for the electrons in the outer rings. All right? So, applying this, there's a couple different ways to think about the electrons in an atom. There's what we call ground state, and this is when the electrons are in the lowest possible ring they can be. All right? You can also think of this as like normal or happy. It's where everybody wants to be. All right? So you're going to have 2 in that first ring, up to 8 in the second ring, up to 18 in the next one, and everything is as low as it can be. All right, so here we've got a nitrogen atom, and we've got our 2 electrons in the bottom ring, and then 5 in the second ring. All right, and these are all exactly where they want to be. All right, so good vocab term here. Pause the video if you need to get that written down. Now, there are times when we can provide energy to the electrons, all right? And we can excite them, all right? So think about it. If you're full of energy, excited people are full of energy, they're kind of bouncing off the walls, things like that. All right, so an excited electron is the same thing. All right, so an excited electron is when we've got this guy here and it jumps up to the next orbital. All right, so it's higher than it should be, so it has more energy than it should be. All right, so temporarily the electrons, we can provide some energy to it, we can push it up into we can use that energy to push it to a higher orbital. What do you think is going to happen once that electron is allowed to kind of go back to normal? So think about it. Based on what we've talked about so far, is that electron going to want to stay in that higher orbital? Hopefully you are saying no. And why not? So the why there would be because the electron wants to be in the lowest possible orbital. So that electron is going to bounce back down to the orbital below. So it's going to go from excited state back to ground state. When that happens, what do you think is going to happen to that energy that was needed to push that electron up to that higher orbital? So if you said that energy was going to be given off, You are exactly right. All right? So when atoms move to the excited state, they don't stay there. They don't want to be there. All right? So they will fall back to their natural ground state. And when that happens, light is given off. And light is a form of energy. All right? So the color of light, this is just a little tidbit of detail. This isn't something that you're going to be tested on, but the color of light actually lets you know how big the jump was. All right, so like red light is kind of low energy light. So if red light is given off, then it was a small jump, maybe from like level 1 to level 2. Whereas if it gives off something like blue light, which is kind of high energy, then what's going on there is maybe you had an electron that was in orbital 1 and it jumped up to like orbital 4 and then fell back down. All right, so the color of the light gave Professor Bohr something to look at and measure and observe and to be able to kind of tell what was going on as far as these transitions. So see if you can take what you learned about this stuff to fill in the blanks here. All right, pause the video and give it a try yourself, and then start it back up to see what the answers are. So orbitals close to the nucleus, they want to be there, so it doesn't take much energy to keep them there. So they have low energy, and orbitals farther from the nucleus have high energy. So when an electron moves from ground state to, all right, so the other state, our other vocab term, this is excited. I feel like I just spelled that wrong, but I think that's just my brain being weird on me. All right, when this happens, when the electron goes from a lower orbital to a higher orbital, all right, so it's going from low energy to high energy, it has to gain some energy. Then when the electrons return to ground state, that electron loses that energy it gained. And we can tell this has happened because that energy is given off as light. All right, so if this isn't making sense, please come to a tutoring session, come talk to me. I'd love to help. But if it is making sense, awesome, and good luck on your test.